In this video, I'm going to teach you how to set up a side-to-side VPN between two Cisco routers. To be able to do this theoretically, the steps to follow are very simple and you see them in this table. You must understand that in order to build a side-by-side VPN, two phases must be built. Phase 1 seeks to create the association of a secure channel for the transmission of cryptographic keys, while Phase 2 will seek the creation of a secure channel, also called IPsec tunnel, which is where the end-to-end encrypted traffic will be transmitted. On a Cisco device, the steps to follow to able to set up a side VPN are as you see in this image. First, you will have to create a cryptographic policy by establishing the parameters to be able to set up Phase 1. Then you will establish the way in which it will be done. Execute the policy. In this case, I will be through a pressure key, and you will also associate it with the peer. That is, the IP address of the one interface of the router or device with which we want to set up the VPN. The third step will be to create a transfer set, which will describe how we want to carry out Phase 2 and what security protocols we will use to finally create a crypto map. We will associate the peer, the transfer set, and the interesting traffic. Something very important that you should keep in mind is that in most cases we have to set up a side VPN. You will find yourself with NAT technologies operating because the majority of users connect to your router will want to have access of the internet. To be able to do this in a turn be able to successfully lift the VPN, you will have to create two extended access lists, one where you capture the interesting traffic or what is going to go to the internet. In this case, the entire site makes the internet, and you will have to deny before a statement that says that the traffic between the site, that is, site there is site VPN have not been net, otherwise your VPN will not rise. In Cisco, you also need to create another extended ASL to be able to define the interesting traffic, that is to say the traffic that lives to transmit between sites. With this clear, let's go to the configuration. This is the topology with which I will work. Do not worry if for now this has some data regarding the IP shoes of the interface, because I will constantly leave this image on the screen so that you do not lose any details regarding what we got doing. First thing I'm going to do is go to PC1 and I will perform a connectivity test to the PC gateway, which in this case is 192.168.10.1. If I go to the router and execute the show IP NAT translation command, you will see that I do not have any data. However, I execute the command to see the access list. You will notice that I'm going to have an access list defined, call it NAT, defining the traffic that goes from site 1 to the internet. That's why if you go to PC1 and run a connectivity test toward the public IP address of both ends, you will notice that I do have full connectivity. With this in mind, let's start the configuration. The first thing you are going to create is a cryptographic policy to leave Phase 1. In this case, we are going to define that the encryption is 3 Ds. The hash is MD5. The authentication is always shared, and the DH group is group 2. Then the pre-shared key and associated with the peer with which you want to do open the VPN. That is why you use the command that you're seeing on the screen. First step is what time to configure the IPsec tunnel. We established a name for the transfer set, which in this case will be called VPN, and we apply the security parameters that we consider relevant. In this case, for encryption, I will use 3Ds, while for integrity and authentication, I will use MD5 and HMAC. Finally, and the 5 map I'm going to associate of the above, that is the peer, the transfer set, and interesting traffic of the VPN. An important thing that you should keep in mind is that the match address VPN command is associated with the access list, which I have not yet created. Therefore, That is why I'm going to apply the change of the cryptographic map to the one interface of R1. And as you see here, it immediately tells us that the crypto phase 1 has gone from the page state to the on states. With this command that you see, I will create an extended access list called VPN, which will allow interesting traffic that is from 192.168.10.0 to 192.168.20.0 located at site 2 of the remote router. We simply have to execute the command and mirror from in R2, which in the remote site to be able to activate the VPN, so I will simply take the command, correct the mirror, that is what was previously the origin will now be the destination, and in turn once was with previously a destination will now be an origin. Also apply of course to access list. I apply the change to crypto map on R2, the one interface. I'm going to do a new connectivity test between this site. That's why I'm going to PS1 and perform a connectivity test. And how are you right now seeing the VPN app without problem? If you go to command show crypto cisconetworking PSA, you will see the phase 1 association that I already have established, which tell me that I actually active between the source and the destination. And turn, if I execute the command show crypto IPsec say SA, you will see all the packet that I encrypted to verify and authenticated encryption, which show that the VPN is fully operational. Something very important to keep in mind is that the show which takes data as if there's a mirror, keeping in mind origin and destination. The question is, what happens if you're working with other brands such as Fortigate or mikrotik? Because if you want to set up a VPN between this site, watch the video here.